All right, so if I take a look at x times y equals 1, I got 1 and 1. Let's see. If I go 1 and 1 on my graph, that's right about there. 2 and 1/2 would probably be right about there. 1/2 and 2 would be up here. My 4s aren't going to fit, but it looks something like that. It's like we've seen this graph, right? We've seen this graph. And if I do the negatives, all right, -1 and -1 is about there. -2 and -1/2 is maybe about there. Oh, -1/2 and -4 is about there. So again, we've seen this graph, but just with different numbers, okay? Now, even though I made it really big, it's really small, because these is like 1/4, 1/2, 3/4, right? So this is going to be what we call our parent function. Our parent function is the most basic of these. It is inversely proportionate, okay? It is an inversely proportionate because as one value, okay, write that down, I want you to watch, write that down, it is inversely proportionate because as one value gets bigger, the other gets smaller, right? See that? Or as one value gets smaller, the other gets bigger. It is inversely proportional. Okay? Now, what can x not be? More than anything, this is the important stuff. X better not be what? X better not be, x cannot equal 0. Totally right. So I'm going to draw a vertical asymptote right there, okay? That's my vertical asymptote. I'm going to write that down, my vertical asymptote. And that's at x equals 0. I also have a horizontal asymptote. Because if x can't be 0, like Cookie Monster says, then y cannot be 0. Because if you have no cookies and you have no friends, you'll have an asymptote at the vertical and at the horizontal. Now, we're going to take this graph and I'm going to move it, okay? I'm going to move it. So, identical graph. Look, identical graph except, okay, one more time, watch. You know this drill. Emily, you watching? Go like this. Okay, my head is inside the parentheses, right? So I'm moving horizontally,
Yes.
right? You think I'm going to the left?
You're
I'm
going to our
going
left,
right.
or you're going to your right?
Yeah, so do the opposite, right? Okay, I'm moving horizontally inside the parentheses. You think I'm moving to the right, but I'm moving to the left. So I'm going to take my graph and I'm going to move it horizontally. How many units? Which way? Right or left?
Left.
Good. And then I'll take my graph down 4. So what I'll do before I put the graph in is just take the asymptotes. So let's take the asymptotes and move them back 2 and down 4. Now I'm going to go regular axes because it's too small. So let me put down my XY axes, okay?
Didn't we learn this before though?
What's that?
We learned like something like that where we were do the opposite.
Yeah, we've learned that. And so it's the same thing again, but with a different function, okay? So I'm going to move, you guys are right, I'm going to move my graph. We're going to go to the left 2 because of the opposite of that. And then I'm going to take my graph down 4 because of the -4. So what I'll do is just take my asymptote. So I'm going to move my asymptotes down 2 and down 4. Now I haven't put the graph in yet. I've just shifted the asymptotes, okay? Does that make sense?
Yes.
Okay, so I haven't graphed it yet. All I've done so far is taken this, asymptotes, put them in. Now I just got to put the graph in. So I have to, okay, so let's put the graph in.
So with the horizontal,
Is it going to be -4? It's going to be horizontal. And the vertical is at -2. Okay, good question. Okay, so here's what I have. So let's take my graph and let's move it. And I'm going to have my graph
like this, and like this. We could look at this on Desmos, but it's faster just to use my brain and your brain because you're not going to be able to use Desmos on a test, right? So if I use Desmos, I'd go parentheses, I could go x plus 2, plus 2, go back, parentheses, over, and then minus 4, and there it is. Same picture I have, correct? Now, the important part is this. Okay, domain. Tell me about the domain of this graph. What can x be and what can x not be? Domain. Domain is the x values, right? So what can x be? Look at this graph. What can x be? How wide is this graph? Really wide. In fact, forever wide, right? So every number you can think of is on this graph except for 1, right? So we're going to say x is equal to all real numbers because every number is there. Okay?
Except one thing, x cannot be what?
0.
Now, where do you see your asymptote? Where's your asymptote?
It's at 1.
Okay, opposite. One more time.
Opposite. Sorry.
So what number here, what number right here creates this? What number here creates this?
The plus.
Negative 2. Negative 2. If x are negative 2, what's negative 2 plus 2? What's
0.
negative 2 plus 2?
0.
Can you divide by 0?
No.
So x can be everything except,
0.
well, how
No,
do
no,
you
not 0. 2.
Okay, negative 2.
Negative 2.
Right.
So we'll say this. X can be anything, but not negative 2, okay? All right, number 3. So number 3 is also going to have a problem. But before I even graph number 3, let me go ahead and put in my xy axis. Okay, do this. Put your xy axis in. I don't know exactly what this thing looks like, but I do know that I'm going to put an asymptote right there. So I want you to draw this in. Okay, I'll put that right there. Okay? Put that right there. Why? I didn't even put it on my calculator, but why did you put an asymptote right there? Yes, smart girl, keep going. Because of the 2. Tell me what. What's 2 minus 2?
0.
Can you divide by 0? So x cannot be 2. That's why it's 0. Asymptote there, okay? Now, what does this look like? Well, it says division. I'll help you with the long division. Okay?
Which is like one of the problems we did for the
Right, exactly. So I'm going to go x minus 2 into 2x plus 8. Let's do some long division. Okay, and I'll show you why I need this long division, because I don't have what I need yet. So let's do this slowly. X goes into 2x. How many times? 2. Very good. Who said that? Nice. And then I'll multiply, and I'll get a 2x minus 4. I'm going to subtract, right? I'll slow down. So x goes into 2x 2 times. Great. That's awesome. Then, like the long division, I'll multiply. 2 times x, 2 times a negative 2. Now I'm going to subtract. It's long division. All right, 2x minus 2x, gone. Now I got to be careful. This is minus and minus. See the minus and minus? So 8 plus 4 is 12. So my answer, another way to write this is actually like this. It's going to be 2 plus 12 over x minus 2. All right? Let's see what that means.
So now, I got to take the graph up 2 also. So this 2 is going to pull my asymptote up to 2. So I'm going to put this asymptote here. So this is 2, okay? So the whole thing got moved up 2. Does that make sense? I rewrote it in a form that's easier to graph. So pull it up to 2, okay? All right, pull it up to 2. So my asymptote goes here, up at 2. And then, almost done. You ready? Gotta listen. What times what makes 12? Give me some answers. What times what makes 12? 2 and 6.
3.
3 and 4. Okay, all those, right? So watch. From right here, watch my pencil. You guys said 2 and 6, right? 1, 2, 3, 4, 5, 6, 1, 2. From the asymptote. I heard 3 and 4. 1, 2, 3, 1, 2, 3, 4. I heard 6 and 2, or 2 and 6, 2, 1, 2, 3, 4, 5, 6. So my graph's going to look something like that. And the negatives as well, right? Right, Victor, you said the negatives. You were right about the negatives. So from here, from the center, from here, I'll go, well, let's go -3 and -4. Let's go -2 and -6. 1, 2, 3, 4, 5, 6. Let's go 1, 2, 3, 4, and -3. And my graph's going to look something like this. Now, you could maybe get that on Desmos, but it won't be as easy to understand. Okay? You might be able to get it on Desmos. So, most important to me right now is this. Okay? Domain. Right here. Look. Right here. You're right, Leslie. What can X better not be? Better not be what? Right here. 2. How wide is this graph? Forever.
Wide.
Except for one spot. What's the one spot? 2. So what's the domain?
Negative. No, 0. No.
All real numbers.
All real numbers except, so the domain is X is equal to all real numbers, everything, right? Except one place. What can X not be? 2. 2. Because if 2's right there, 2 minus 2 is what?
0.
Good, okay. All right, turn the page. Okay. Actually, you don't need to turn the page because we just did that one, okay? You don't need to. Okay, so homework. And we're going to do it together. Page 177, 1 through 6. We're going to take a mass break. Let's go outside. Everybody go outside. Let's teach Mrs. Richter 21, okay? Let's go outside. Everybody, let's teach her 21, okay? Everybody go outside.
Well, I'm going to show you some
Okay, we'll go now, but you know I need you gotta be good.
Let the girl from the hood.
Oh, let me take you the shirt.
Look at this picture I took.
Let me give you that.
Come on, guys, come on, everybody out. We're gonna play 21.
Yeah. Dude, you literally just let me see it. I was like, what?
Oh, my bad.
No, going that way. Going that way.
No, look.
Going that way.
Agarra tu comida, güey.
Sorry. Ahí te va, ahí te va, ahí te va. Ahí te va. Dude, I got a picture of you, babe. Look. I got a picture of you.
Let me see.
Oh, you're in here, bro.
Ya tú digas tú.
Look.
Victor.
Bro, I'm dead. Look.
Yeah.
What happened?
Yeah.
This shit is funny.
What happened?
Did you get a picture to Angel? Of you sleeping? No? That's it, can I tell you?
They were gonna go to the bathroom. Goofy?
Looks like a fun party.
No.
All right. Okay, guys, come on, sit up here. Victor, do you want to take some of them?
Think they have enough focus?
Are we gonna keep doing it?
I don't know.
I'm going to separate them. All right. All right, Victor, come on.
What are you gonna do?
Kevin, sit down, please. All right, we have homework, we're going to do it. No! Okay, now, only 6 problems. You can use, if you need to use Desmos, you can use Desmos. Let's take a look at it. Yeah, let's take a look at it.
Yeah.
This honey smelled in less than 5 minutes.
There's another one that is dropping that I'm gonna.
All right, let's take a look what you have.
There it is. Hey, let's go to page, am I still recording? Oh, wow.